So hi everyone, I'm really happy to be here presenting for you. So let's start because maybe we'll be short on time. So as Ian introduced me, I'm Pascale Campos. I work for Nubank and I'm from Brazil. So I'm going to talk today about building a sustainable code base, and I'd like to say what was the motivation for that talk. And the thing is, when I first started Nubank last year in January, I entered a new team and our tech manager just went on vacation. So we needed to start a new service from scratch. And it was a new team. It was only me and Marcelo that became my friend. And we had like no idea where to start. It was a new company for both of us. So we decided that we were going to open GitHub, open a lot of repos, and try to choose the ones that seems better for us so we could use as a source of truth. Anna would be the better person to help us because she was our tech manager. She already had 2 years of experience at Nubank, but she was on vacation, so we needed to do that way. So what was really amazing for us that after 2 weeks, we realized how much code to production, how feedback while developing, and we were amazed about that. Like it took way less time and effort than we thought it would just for shipping code to production. So it was crazy. 2 new people at a new company, shipping code to production in a new language. Marcel and I were both familiar with the functional paradigm, so it helped us a lot. But everything was new to us, and we were already able to deliver things to production. So with almost no guidance, because we didn't know anyone at the company at that time. So we started to ask ourselves why. Why it happened. It was amazing, and I tried to find some evidence to be able to give this talk. So this was the motivation. Just a little bit about Nubank. We are a digital bank in Brazil. We have more than 25 million customers. So just to have an idea, according to Forbes, we are the best bank in Brazil, and we are the biggest digital bank in the world, except from China. So we have more than 500 engineers, more than 400 servers. We are already in Mexico now. So since last year, we started our operations in Mexico. We are also have an office in Berlin for data. And as I said, more than 25 million customers, just to have an idea about the company. So when we are talking about that much services, we can imagine how hard it is to understand all the problems about these distributed systems. But today in this talk, I want to focus on the code base part, not about the communication between them. So the first question that came to my mind while looking to all those services in GitHub to try to select ones for us to use as a source of truth were what were the main characteristics? What do all those services have in common? What are the patterns between them? And I came with 3 things that were functional programming. All of them are using functional programming. All of them rely a lot on tests, and all of them are using hexagonal architecture. So these were the things that were in common in all those like 400 services. So let's start talking a little bit about functional programming. First thing is, we as functional programmers, we borrow the concept of functions from math. So when we are talking about pure functions, we are referencing these mathematical functions, and we know they are different from methods or procedures from other, when we are talking about programming, you often use those terms, but when we talk about methods and procedures, those functions can do a lot of things, right? They can write to database, they can read from files, but we want to narrow our possibilities with those functions. So we started to use these pure functions, and they are really similar to math. In math, we have a function has a domain and a range. And when we are talking about programming and pure functions, we have our arguments and our return values, right? So those mathematical functions, they are referential transparent. So you can replace a function with its return value, and they are timeless. This means that it does not matter when you're going to solve that function, it's always going to give you the same output. And the idea is it's given the same input, always the same output, and timeless. This never change. And we know that functional programming is about those pure functions, right? So just repeating to be clear, giving its inputs, it's always return the same output. We don't have any side effects like saving to a database, sending an email, producing a message. We don't have those things. And we can also use the term referential transparency, and the idea is that we are going to return the value, like we are going to replace the function call with its return value. And we have this power because the return is always the same given an input. So those two ideas are interchangeable. But here's a really important thing. What about the impure functions, right? We know that in order to have a user code, we need to have impure functions because our program needs to have an input, it needs to have an output, and we really want to be able to interact with our program. So all those interactions, they happen inside these impure functions. So when we read a file, it changes in time. After we write to a database, those things are going to change. So we need to, those things, they happen inside the impure functions, right? And we need to talk about them. Because as much as functional programmers love to talk about pure things, we need to talk about effects also. And it's a really important topic to be discussed because they are the tricky part, right? So we need to think well about them in order to not mess the rest of our code base. So how are we going to deal with these effects? So one thing to keep in mind is that if you call an impure function inside a pure function, you no longer have a pure function, right? So you need to think how I'm going to architecture my functions so only the impure functions are going to call the pure ones. So I need to have this chain. This chain is going to start with an impure function calling all the pure ones. So when we are writing our functions, we always need to have that in mind. We need to structure our code in a way that we can maximize the pure functions, right? We don't want to infect our functional code with imperative code. So we need to separate what we build, the effects from the pure functions. The effects can affect everything. And what we want is to maximize our functional programming, right? Functional programming, pure functions, and to minimize and isolate our impure functions. That's the imperative code that we have in our code base. So what we want is to be as functional as we can. And if we want to get the best from pure functions, we need to limit this amount of imperative code. And one thing that I really like to say is that if a function could be pure and it's not, we are doing it wrong. So we always need to look to that and try to change and be mindful about that when developing. Another really important concept is about immutability versus mutability, and I really like this drawing. It's from the book Joy of Closure. It's really, really nice. So the idea here is that you have the book, and the book is your identity. So when we want to change something in the draw, you are going to turn the page and draw a new thing in the end, right? So what does that mean? The acting of turning those pages represents the state of the draw during that point of time. So when you stop in a page and observe the state, when you stop in a page, you're observing a state in a certain point of time. But now let's look to the other draw. In this other one, if you change something in your draw, you need to erase something, or you need to do another thing, but you don't know when that happened. So the thing here is that you have just you don't have now the concept of identity and state. You just mix it, both of them. And now they're blended and you just lost the concept of time. So this is a really nice thing to think about. When you have immutability, you can have the identity, that's your book. You can have the state, that's the page in a certain point of time. But when you don't have that, you just blended everything and lost the concept of time. So when you have pure functions and immutability, it's way easier for you to debug your code because with pure functions, you know that given the input, the output is always the same. And you know the return value of that function can be replaced with its call, making it really easy to reason about that code. And with immutability, you always have new pages, right? So if you change something, you don't need to go deep in the code to understand which functions are mutating that page. So this combo gives you a lot of power and speed when developing. And when programming with functional language, you can really focus on what matters. That's data, calculations, functions, and not like classes, interfaces, and boilerplate code. So this is what I was trying to say at the beginning when I said, oh, we deliver a lot of business code in 2 weeks. We were not worrying about code that was not valuable for the company. So you can move faster because it's easier to test, it's easier to focus on data, and the intent of your code is clear. So you get to try new things way faster. Another topic that's also nice is the idea of eliminating shared state, so order does not matter. And here I'm going to use an idea that Eric Norman said, I think it's really nice. Like you can eliminate all those shared things so they can be independent. So when you give someone a task that they don't need to talk to anybody, they don't need to wait for anything for anybody, you don't need to share tools, so you just can do things at your own pace, and that's also really powerful. And also get this combo with immutability and pure functions. So it's really, really nice to have this, the order does not matter, because when you have to care about order, you need to care about functions mutate things in all places. It's way harder for you to understand your code and reason about it. So what we want to be as functional as we can, to be able to move faster and to be able to move with more confidence, right? So the next step is about tests. We want to have a sustainable code base, and if we want to have a sustainable code base, we need to have tests. So tests are really important to give developers confidence to extend or to change code. Also, if someone new enters your team, this person, if he or she changes things, it's going to break, and you have the test feedback. So this person will have more independence when changing things, because it can look to the test and try to move by him or herself. So it's really nice to have this automatic feedback. And when trying to understand a code that we didn't write, we can always check the tests to see if, to understand what the person who wrote was expecting from that code, right? Also, it works as a live documentation. So if we change the code, we need to change the test. So really like job subject here, but it's important to know that tests don't get stale, and that's powerful also. And what we need to know about tests, about the feedback. So is our program doing what we expected it to do? How we can check the quality of this feedback, right? One spoiler here, it's not about 100% coverage, but how we can check the quality of the test feedback. Fourth thing is about accuracy. So if a test fails, can we determine exactly which portion of the code has failed? So how long do it take for us to know where it failed? So as granular as it is, the more accuracy we can get. So it's way faster if we have small functions with no dependencies from the outside world, right? So here we can remember about pure functions. We have a lot of accuracy with them since they do not depend on any other functions. So if a function fails, we know exactly where it failed. Also, we want speed. The faster we find the test is failing, the sooner we can identify the problem, and smaller it will be the impact. So we want tests that are simple to write and simple to maintain and faster to run. Here we can think about integration tests, because integration tests take longer to write and to run. Because we need to mock things, we need to create states, sometimes we forget to mock things. So we need, before creating all the state in an integration test, before writing the real test. And it also takes way longer to run in our CI. And so given that, we want unit tests, a lot of them, because they are faster to write, they are faster to run and to maintain. So the idea here is that we want to have more units than integration tests. And another really important thing is that, can we trust the outcome of our tests? So if the outcome of our test changes from executing one execution to another, even if nothing changes, the code or the dependencies, we don't need to have this kind of test, right? Because we don't rely on them. So here we can think about end-to-end tests, and at Nubank we just decided to kill all of them. I'm not going to enter deep in this subject because we don't have a lot of time, but we replace them with contract tests. So it is a real problem. It takes a lot to run. You cannot rely on them. So at Nubank, we just killed it. So now we have accuracy with functional programming, since most of our code base is composed by pure functions. We can cover it using unit tests, right? And when we talk about integration test, accuracy is lower since we're not testing a function, but a flow. We have speed because we are using pure functions. We can just test everything using the console, things like that. We don't need to mock dependencies, right? And we also don't have any trained tests because they always fail with strange problems. They have latency, asynchronous operations, garbage collector. All those things are a problem when we talk about trained tests. So, okay, how can we design our code in order to take advantage of all those things that I was talking to you? So the first thing, we always want applications that are easy to give maintenance and that have low tech debt, right? We need applications that are simple and easy to work on. And a hard thing about that is that maintainable, it's hard. It's a long-term concept, right? In the beginning, when your project has just started, we have like few lines of code, 3 people working on it, just a couple dependencies. So you don't see the value of maintainability. So, but as soon as our team starts to grow, things get harder, and the bug can show you that all your architecture was wrong, right? So this is the reason that's so important to think about architecture since the beginning. Sorry, I just clicked in a wrong thing here. Sorry, people. I need to. Okay, just a second. Okay, I think everything is okay, but if it's not, I think someone can tell me.
It's all fine. Yep.
Okay, great. Sorry for that. Okay, so I was talking about maintainability. That's a long-term concept, and this is the reason it's so important to think about it since the beginning, even if you don't see the value since the beginning, right? So our first attempt was to use hexagonal architecture, and the basic idea is that you have your domain model where you're going to have all the functions pure and immutability here. So this is the reason why it's green, because you have pure functions and mutable data. And here you're going to have all the rules about your domain. So if you're using accountability, here are the things, where you're going to find the functions about how transactions done, which operations you can do, and things like that. So here, all the rules about your domain are going to be inside your domain model. And you know that these functions are pure and immutable, right? In the second layer, you're going to have your application or here you can think about the controller, the one that's going to be responsible for controlling all your flow, right? So when you receive an HTTP call, is going to be inside it's going to arrive in a port. The port's going to do something. It's going to pass through the adapter. It's going to do something with the data. It's going to be in your controller. So your controller know, okay, now I need to call a logic function. Now I need to call a producer. I need to call my database. So the controller is responsible for taking care of everything. But here we can already find some impure functions and some mutable data. That's things that we don't like. It's not all of those functions. This is the reason why it's like yellow, right? So we have some impure code here. It's not the best, but we have. And in our third layer is known as ports. Here is where we interact with the external world, right? We are going to talk to our database, to third parties, to our message broker. So here it's more than fine to have your impure functions. We want to have our impure functions here and mutable code here. So that's okay. It's red, but we know where they are. So it's isolated. So it's great. We know they are here. That's the thing. Okay. So what we want with hexagonal architecture is to separate business logic from I/O. So we want to structure our code in a way that protects the domain from the technical stuff. So we can define our business rules, what are the applications rules, and the infra code. So it's easier to develop a feature, so because you know in which layers you need to work on, right? And we also we get that. We want testing isolation with mocks and stubs because you don't want to rely on real database or external APIs. So we can easily mock and stub things. Why? Because we use dependency injection. So in order to achieve that, the dependencies are going to be passed as arguments to our function. So when we run in production, we use the real database, but for tests, we can like pass a hard-coded file, for example, in our argument instead of the database. So okay, what were the first discovery that we had? That hard things in object-oriented programming can be really easy in functional programming. And here I'm talking about tests. So remember that in hexagonal architecture, we have our impure functions in the boundaries, right? Just remembering here, it's in the boundaries. We call that the IO layer or the ports, and that's where the side effects are generated. So here we are having the HTTP request, the message. So it's really nice to realize that we can isolate and control the side effects in this layer, right? And understand what isolation is considered isolated when all of the outside world is fed through arguments. So we can come to the conclusion that every pure function is isolated. So the pure so really nice. Given that all the argument, given that all the pure functions, all the pure functions are isolated, but not all the isolated functions are pure, right? Just imagine you are going to receive your database and your argument, you're going to receive your database, your user, all of that pure arguments, but you're going to call the database safe inside it. So it's not pure, but it's isolated. Okay, just to understand better those concepts. The problem is isolation is the dual of the encapsulation. So that means that encapsulation means that the object has a state and the outside world knows nothing about it unless it's made explicitly available to it through getters and setters. And isolation means a function knows nothing about the external world unless it's inputted on it. So can you realize how it's the opposite? And isolated functions are really easy to test given like for free when doing functional programming. But in object-oriented programming, there are problems because they are violating the encapsulation principle. So when developing with object-oriented code, you need to find an intersection between them. So not a subset. And it's way easier to work in a subset than it is to work in intersection, right? So it's really hard to find the balance between both. Given that these concepts are almost the opposite and object-oriented program like has a lot of patterns and good practices, it's really hard to find a team to maintain this balance. Imagine for a junior developer that has just started to learn all those things, how will that person know how to balance is isolation with encapsulation? So it's really easy to break this balance and lose the power of testing easily. But this is not a problem in functional programming because the minimum we expect from a good functional design is to have pure functions. And those are a subset of the isolated ones, right? So if you're doing pure functions, you're doing isolated and you just get the easiness of tests for free. So we want to have as many pure functions as we can to get all those benefits. We know a pure function cannot call an impure one, otherwise it would be impure. And Haskell is a really nice language to realize about that because Haskell expects everything to be pure. Elixir and Clojure, for example, does not have that in the compiler. Like, so when you write coding in Haskell, the compiler helps you checking if that function is pure or not. Because if you wrote an impure function and forgot to declare its type as IO, it's going to throw you an error. So in order to maintain as many pure functions as you can, you just push impure code to the boundaries. So the impure functions can call the chain of pure functions. So it's when you do that in Haskell, you are doing ports and adapters, you are doing hexagonal architecture. So it's really nice to realize how the language helps you get to that architecture. And so good functional programming design is about ports and adapters, and Haskell is a great language for you to find out about that. It was a great discovery. It made a lot of sense to us. So that's all the reasons we could ship a lot of code to production in those days. And now, but we were questioning ourselves, are we leveraging functional programming to its max? Because our second layer that I just showed you, that was yellow, it still has some imperative codes and side effects. So it was not the best. We still had, for example, integration tests in our controllers. How could we change that? And why don't we want imperative code? Because it's harder to reason about. Why it's harder to reason about? When I call this function block and I pass card, DB, and producer, if I look to its return, it could be like true. So I have no idea what happens inside that function. I need to go inside that function and try to understand, okay, now I see that I have a producer, I'm calling the DB. why this happens? Because I have indirect outputs inside my function. I don't have direct output. So I need to enter to understand what's happening. The second thing that's harder to compose, because here I'm calling things inside a map. So imagine the block fails and I'm calling the DB, I'm calling things. If it fails at the second card, the rest of them are not going to work. So I have an inconsistent state. 2 things worked and 3 not, for example, because I'm already doing everything while I'm iterating. And also I'm passing my infrastructure to the codes. You see the database and the producer. And it's harder to test because I need to have mocks and integration tests, right? Since I'm passing the DB and things like that. So it's harder than unit tests. And the feedback slower, as I told you, integration tests are slower. So if you stop and think, we're having more integration than unit tests because our controller and our ports are impure. We want to have more unit integration tests. That's what I told you. So what can we do? We are having less pure functions than we want since our second layer is impure. Our tests are not that fast because we are having lots and lots of integration tests. So everything of that is making it harder to maintain. So we decided to try another approach, hexagonal architecture with dependency rejection. So the idea here that we want to decouple decisions from effects. We want to decouple the intent from the execution. So another example, now I'm calling the same function block, but this time you see I'm not passing my DB here. And what's the return? The return is a map with the datums, that's the things that I want to save in my database, and the message that I want to produce, right? So now I don't need to see inside that function because when I see the return, I understand what's the intent of that. So now here, I'm just producing the data structures that are telling me what I need to do. I'm decouple the intent from the execution. Now this function just tells the intent of it. I want to produce something to the database. I want to produce a message, but I'm not I'm just creating data structures. I'm not calling a database. I'm not calling a message broker. So it's way easier to compose now. I can say all the effects that I want, and only at the end I'm going to do them. So now I have atomic operations because, as we stated before, we would say things to the database and only after produce the message. It was way harder to recover if an error happened and to compose. And now we don't have that. We are only in the end, we're saving and producing all the message, not during that. We also have data as first-class citizens. That's a thing that's really powerful because you see now the return of my functions are flowing through all my program. I can see what functions are doing. I don't have outputs that are indirect. All of them are direct. It's declarative. And now I get the second layer to be pure also. So second layer without side effects. That's really, really, really powerful. And we became way more expressive. So now we have more pure functions. We can test the controllers with unit tests, and we gain a lot in maintainability. So that's it. Thanks, everyone. I don't know if you have any questions. Yeah.
Yes, actually, there are some questions in the session Q&A. So let me just go to the panel. We have just 2 more minutes. So let's have 1 or 2 questions. Yeah, that's fine with you. So there is one question. What is your opinion on more advanced functional programming tools, like first class, maybe optional types like functors, applicatives, and monads in regards to the sustainability of application?
Mm-hmm. This is a great question. As I told you, at Nubank, we have more than 500 engineers. And we are a company that is like 6 years old. So imagine how hard it is to find functional programmers, like 500, you know. I think we that work with functional programming know how hard it can be. And what I realized in that time is that's really important to have a code that's like maintainable and easy to read. We have some services at Nubank that use monads and things like that, but we also use some of these concepts, but my idea is that if you're going to use, try to encapsulate them as much as you can. So if someone will enter the team, it can have a lot of time to understand about functional programming and use this like framework or that lib, and only after that, when okay, now I have confidence, I can try to understand how it's done. Like since the beginning, putting models and things like that, I think it makes everything harder for new people. And if you're a company of like 500 people, you always need to think about that and think about hiring. So how can we have like a functional code base, but that's easier to understand? So in my team, we try to avoid as much as possible those things. And we think now when I look to the code, I'm happy with that, because we have a functional code base, but for new people, it's easy to understand. So that's my idea about the topic.